Okay, so welcome everyone. Today is June 13th. We're going to discuss the auto-scaling workstream as part of working group serving. Let me see if I can pull up the agenda. Okay. All right, so we on the Slack channel mentioned that we wanted to discuss Clayton's doc about the various ways to set up your auto-scaling on basically model servers. And so there were a variety of scenarios that were discussed, and we wanted to maybe cover these today and make sure that, I guess, we all kind of have, a good understanding of what this is suggesting, and whether we feel like some of this capability should be inside Kubernetes versus what would be in the model servers. I know during the working group serving meeting yesterday, we discussed very briefly that there was a thread with the TGI folks on incorporating some of these metrics into the model servers such that the auto-scaling mechanism can just use those directly. So I don't know if that's a good place to start.
I was going to actually ask too, like I could probably break the doc into two sections. There's what if you have a single, like what's the easy path? That's what I see a lot of people hitting, which is I have a set of homogeneous hardware and homogeneous workload. What's the best way to autoscale? So that's really variations or A1 and A2. And then I have the more advanced, which is a little bit less developed because start with the easy one, but the more advanced scenario gets into things like heterogeneous hardware, and there's lots of reasons why you might want different accelerators, whether it's just you don't have enough of the kind you want, or you've got multiple generations, and some of them are cheaper. Older accelerators still can run models. They can't run them as fast, but for shorter requests, they might be able to run equivalently as fast as longer requests on newer accelerators. And then obviously like LoRa, and there's some more advanced cases. So I figured like today, I think it would be good to focus on the homogeneous use cases, but I would actually love for people who are interested, and we could probably follow up. I'd love for people who are interested in the heterogeneous use cases to discuss. And I suspect a lot of what we discussed in the homogeneous will carry over. And I think, like maybe this was kind of written in a very, Ray and I were doing some internal iteration where we were asking each other questions and then trying to get to a long form description. This definitely would deserve being summarized. But I think in the homogeneous use case, the way I had framed it was you have a latency objective in almost all use cases. Even if I don't really care about latency, or, what's the best that I can get as cheaply as possible. That's still a latency policy. It's just you don't care about latency. And once you've made that choice, the hardware responds in different ways. So like the novel thing being that LLMs, the bigger the request and the bigger the response, the more compute it takes, thus the longer it takes. And so, and then the more parallel requests you do, the slower all of your parallel requests get, but you can make progress on them. The alternative is you queue requests. Queuing is kind of uncommon in regular web applications today. If you're writing an event-driven app, you might explicitly model a queue, but not every HTTP server, HTTP framework kind of has that mental model of a queue of incoming resources. But almost all LLM model servers have that queuing construct. So I kind of broke it down into the admission decision to start running a new request has those three categories: queue, accept, and reject. that are different for different use cases. And then there's uh, depending on what your objective is, you might choose different reasons. So just as a high level summary, does any of that description, like the people with experience auto scaling, does any of that sound incorrect? Like I've been trying to test this, but we're looking for people to contradict it or to bring subtleties that aren't showing up. And thank you for the folks who did comment. We caught a couple of them, but I'm looking for like kind of that validation at a high level that this matches people's experience.
I guess like hey, by the way, this is my first time joining this meeting. I'm Rob. I'm from Neuromagic, and I work
Rob.
on VLLM. I'm a committer to the project. So I think that this makes a lot of sense. The only thing that I kind of think is like different about LLMs as it relates to like typical typical kind of like inference serving is specifically as it relates to this queuing and concurrency concept. The continuous batching and like internal management of the queuing and concurrency like definitely creates some like surprising dynamics, I think, which is like especially like you see LLMs are like a memory bound workload, so from a GPU perspective. And so as you add more and more requests, like you actually typically don't see much of a hit on the inter-token latency, when you go from like one concurrent request to like 16 or 32 concurrent requests. But all of a sudden, like you can hit these like critical points where as the request rate goes up, you start spending too much time processing the prompts, and this just causes the whole like sort of system to unwind. So it does have this dynamic where like at the lower levels of concurrency, like you're actually able to like handle more and more requests. And then all of a sudden you hit this like critical threshold where, too much time is being spent processing the prompts and it can't get batched together. And so all of that nuance, I do think like makes it difficult to like configure the auto scaling like completely properly. And like I think we want to have some nuance around like what we mean by concurrency and what we mean by queuing because of this like fact. So that wasn't a very helpful comment, but that's just like the only nuance I would sort of talk about like as it relates to the queuing and concurrency is like how all these things kind of intersect and this like critical threshold that some of these servers have when because they're handling all this stuff internally, I guess.
And actually, that's really helpful. And I was going to say, to add to what you're saying, one of the assumptions that I think we started with, last year was continuous batching is kind of the state of the art. And so any system that predates continuous batching, we weren't going to spend a lot of mental energy on looking forward. One of the things, I know VLLM has PRs open for various aspects of this with mixed mode batching and prefill chunking.
Yep.
Like it's a different mental model. How do you think about the difference between continuous batching and like any of the chunking approaches going forward? Do you see them as more of a smooth continuum, or do you see other step change where you'd expect to have that flexibility to actually mitigate some of the challenges you're talking about with step function trade-offs?
Yeah. So chunked prefill in particular is going to be turned on by default relatively soon in VLM. And this will really help smoothing out some of these dynamics at higher request rates. Like specifically what chunk prefill is trying to do is like push this critical threshold and make the smoothness at which you hit the critical threshold, moving it to higher request rates and making the path of moving from from where we are now, where like you can get overloaded very suddenly and not be able to catch up, and make the process of that happen more smoothly. And this is going to be turned on by default pretty soon. We're just kind of like have it in beta stage right now while we're like ironing out, any issues with it, just because it's like a big, kind of change. I don't think this is more of like a tweak to the overall like continuous batching logic. Like there still will be that dynamic that I talked about where like the server will be smooth in terms of latency and then all of a sudden hit a critical threshold. That will still kind of be something that will happen with chunk prefill, but it will be a bit more of a it will be a bit more of a it will be mitigated but like that fundamental dynamic will still kind of exist. There's a separate kind of like proposal for like something called dynamic split fuse. I think it's called dynamic split fuse.
We call it, and so can you, because I think terminology, and this would be a great, like, this is partially why we want to do this, is like when we have different terminology in use from different research papers and different, like at Google, there's a different name internally for this technique. It would actually be good to, like, anytime we get a terminology, like I know chunk prefill, the splitwise paper used, called it mixed batching, but it'd be great to actually, as a group, when we get these names, is like actually ask what y'all were wanting to call it and see if we can drive some consistency across.
Yeah. All right. So let me rephrase. So sorry, chunked prefill and then dynamic splitwise. Dynamic split fuse are the same thing. These are the same general idea. This is also sometimes called Sarathi serve.
Yep.
Sarathi
From the paper.
Yeah, and then I think Sarathi is one thing, and then dynamic split fuse is what like the Microsoft people called it in the
Deep speed.
deep speed, yep. And then in VLM we've been calling this chunked prefill, but those all refer to like the same general idea of overlapping prefill compute with decode compute. And all of those address the same idea of trying to like move the critical threshold further on the request rate and also smooth out intertoken latency and smooth out, the transition from healthy to unhealthy in terms of the, latency that you're getting. There's a separate technique called splitwise, which is a different like parallelism technique that puts prefill compute on one GPU and decode compute on a different GPU. This is like very, very experimental and like not something we have like any real prototypes around, and like will not be.
And we call this disaggregated serving at Google.
Sure.
So this is something that's been used for a while. I think one of the original papers, there've been variations of it. That one's there's like different modes of that, but we generally call it disaggregated serving. And then there's like fixed ratio, where you've got much more of like, you design the whole thing together and the prefills send to the decodes. But then we don't have a great name for this, but we called it like microservice disaggregation, where the ratio between the front ends and the back ends is dynamic. The dynamism that we see actually starts to look a little bit like the split, which paper is it? The splitwise paper, where there's actually multiple pools of different, that in my mind, that section I have at the bottom on heterogeneous, a lot of the heterogeneous thinking we've kind of been going through is there are reasons that you might have different chunks of hardware. Some of them might be mixed phases, some of them might be split phases. I think that lines up with what you're describing from that paper, and we agree it's not a lot of people have implemented it, but we kind of expect that there'll be value in it, maybe less value now that chunk prefill is becoming. So like we're kind of been working through some of that ourselves as well.
Yeah, I guess like what I would say about those is like I'm a little bit skeptical of like I'm a little bit skeptical of this, mostly because like there are some like pretty like fundamental limitations, because like what will have to happen is the KV caches, which is like pretty consistent, pretty large overall like memory, will have to be synchronized like across you will have to move those from one GPU to another GPU, and like it's going to be like very tricky to make that performant. I think that to like actually realize performance acceleration from these, like there's going to be like a lot of engineering that has to happen, and like I don't really expect this to be like production ready anytime soon.
And actually I think, Robert, to your point, like that one we're discussing in serving under the multi-host inference, because multi-host inference has similar but not identical challenges. But the general like network topology for multiple hosts so that you can line them up to ensure that you have fast network is but not the only prereq to some scenarios for disaggregated serving. Not the split GPU, but like where you would actually go to the microservice based and totally agree. Like, yeah, like I think timing wise, this would actually be, Ray, this is maybe something we should think about for serving in general, is think about timeframes where, like, Rob, your intuitions about when these things become production ready. We as a group can say, like, well, what are we preparing for next year? We're preparing for, this may become possible. Here's the things we'd have to do to get there. It may not be possible in that time frame. So that's super useful for us to
Totally.
hear.
I also think that optimization is like very much targeted at like very, very, very high request rate kind of systems where like I kind of talked about like every time step inside of these servers, you can either do a prefill or a decode. And like what ends up happening is like as you get more and more requests, more time starts being spent in prefill, and then only one request can make progress, during that time. And so these techniques like chunk prefill are very much targeted at these like higher request rate scenarios. And something like disaggregated prefill, which I think is what you guys were calling it. I'm trying to use the right terminology.
We call it
Like,
disaggregated serving generally, but it is splitting the two phases into separate software chunks. So yeah.
Yep. And that stuff like is very much hitting on these like really high end situations where like this type of stuff really matters. So like I do think that more like rank and file, enterprise deployments of LLMs are going to be like less likely to adopt those types of features because it's just like really targeted at super high utilization, and then additionally like it is more complex to kind of tune. So,
and I think that that's a great point that I think we're calling out to is one of the trends that I think is kind of implicit in some of what we've been seeing is that there are strong advantages in densifying your model servers. And so what we've actually seen, and Zhezhen and I chat about this as well, is like the bigger you get, the more likely you are to move to kind of more like LoRa. Like today, if we survey the landscape, the biggest folks tend to run lots of LoRa adapters on shared model servers at very high scale, because the operational efficiency is much better. And that drives, for some of the early adopters in that space of LoRa, also tend to be the high traffic ones. So that's been something I think that as part of the serving working group, we want to like think about maybe categorizing those as like the enterprise broad, the super dense, and then maybe like the very high scale, and those would each kind of have. So like that's great clarification we can bring. John?
Yeah, so I had a question on the disaggregated serving, right? We're talking about moving KV caches between accelerators. Like, are we trying to use the ICI for the data movement, or like falling back to data center networking?
I was going to actually say like I think we want to talk about autoscaling scenarios. That is in the more heterogeneous or more complex autoscaling scenarios. I think we could have a whole discussion on that. Why don't we move that to the multi-host discussion, John? Because I agree. I think that's a factor, but maybe like, or we can follow up offline or whatever on that one. So maybe going back like to broad questions, I think, Rob, like that's a really key insight that the way that you see it is it's a bit smoother. Like, and I kind of like everybody has different graphs of throughput versus latency, depending on which settings they have, the size of their inputs, the size of their outputs. A lot of what kind of trying to get here would be like, what are the core things that'll be durable for a year or more, even as better techniques come online inside the model servers. When you hit the critical threshold, do you see that as a very sharp transition? Because I think like, to me, it would be one of the nice things that, at least looking from the outside, is that you actually can have longer and longer queues, and in some cases do more and more parallel work. The efficiency that we've seen in some of the simulations doesn't drop off as badly. Is that critical threshold, from what you've seen, do you think it's going to get more of a sharp spike, or do you actually think that there's ways that it'll be a less of a sharp spike, so that operationally you have that advantage of being able to go overshoot and not see a dramatic drop in latency or dramatic hit to latency?
Yeah. So when I'm talking about like a critical threshold, more what I'm thinking about is like the chart I'm imagining in my head is like on the x-axis request rate, so just queries per second, and on the y-axis like overall end-to-end latency. And what I'm trying to say is like moving from like a request rate on average of 2 to 3 can have like surprisingly big differences because of this. But so that's what I mean by like these critical thresholds are like very, very sharp, where it's like, you know, if you get the server into equilibrium at 2 requests per second, like you can have much different latency numbers than at 3 requests per second. This is what I mean. So transitioning from, you know, a system that for 30 seconds is under a request rate of 2 to a request rate of 3 actually does happen pretty smoothly. But it's more just like once you get like the equilibrium state at any given request rate can have this like sharp curve associated with it. And so in some ways, like what I want to argue is that like concurrency, like the concurrency in the system is actually like the wrong metric to be looking at as it relates to or it's only a proxy for what you like actually care about, which is like, are you moving from this healthy state to unhealthy state in aggregate? And the thing that's challenging about using concurrency as that proxy is that depending on the model size, the GPU, the number of input tokens, the number of output tokens that a request has, you're going to want to have a totally different, you know, kind of like concurrency metric that you're scaling on. Like, you know, if you have a RAG use case with 2,000 prompt tokens versus a chat use case with 100 prompt tokens, the location of that critical threshold is going to be like quite different across your servers. And so concurrency, I think, is like the baseline thing that we should be thinking about. But I think if we could go like more
necessary, but not sufficient, I think.
Exactly. Like if we could get more granular with like, you know, usually VLM has like 3 states that a request can be in. It could be in running where it's active, which is effectively concurrency. It could be in waiting, which means like it's in the queue but hasn't yet been added to the batch, or it could be swapped, which means that it's like on pause for a second. So really like the thing that you would want to like actually autoscale on is this like waiting queue and swapped queue, because these are the things that are going to be telling you like this server is overloaded. Like we should, so that's kind of like what I wanted to say is like there's actually like 3 sort of like buckets of states that requests can be in. And like if we could target this like waiting queue inside of VLM, like we could have a metric that was like agnostic to the workload, right? Like it wouldn't matter if it was a 70B model on an A100 or a 7B model on an A10. Like it would just be able to see like, is this server in healthy state or unhealthy state? Yes or no, like auto scale based on that.
And so then I think like, so yeah, and the doc was written from the perspective of like, you know, what could you do now? And I think some of what you're alluding to with the like necessary but not sufficient is the load measurement is actually is more important. It's kind of the sum of squares of weight of the tokens on decode latency. It's not a huge variation, but it's there and it matters. And it's also the size of the input, and those do vary, and those vary over time. In the doc, right now, I'm just using traffic distribution as a shorthand for this is a future problem. I actually think it would be great for us as a working group. And like Ray and I can like find some folks to do this. We should write out that kind of next step, I think, based on what you're saying, Rob, like the criticality thresholds, healthy or unhealthy, the uniform measurement, that's all kind of like today's state. The next is like assessing load. This has come up in some other discussions about, you know, some of this is to actually lay the groundwork for some other discussions I think we'd like to have around how do you, at a high level, direct traffic to model server instances. And autoscaling is one way to grow the number of backends, but there are much more sophisticated strategies that some people are employing. If you have LoRa, there's advantages to like concentrating certain LoRa requests on some servers. And so the input to that discussion really, I think, is, can we come up with a model that makes sense in the model servers? Can we come up with an idealized model of capacity load that hides as much of the detail, passes as much as possible to the model server, so the model servers kind of own that? And then, you know, the traffic direction is working on the kind of that idealized model. And then we have a nice separation of responsibilities. And if people want to go do more sophisticated stuff, they can, you know, tweak the model servers. If people just want to get it working, they can deal with the model server. And then maybe the next step for the serving working group is to say, like, what would it look like to think about the queuing and the use case definition at a high level? Evan?
Cool.
Thanks. Hey, Rob. Quick question, two questions actually. Does VLM currently expose metrics on those internal queue states in concurrency so you could actually track those things? And two, when you're talking about the hitting those critical thresholds, do you have a sense of like what underlying, like is that under the hood, is it becoming like the GPU becoming compute bound at those points, or do you have a sense of like what's actually causing those under the hood? Because you said it obviously can vary depending on the underlying hardware as well as requests for like queries per second. But right, there must be some fundamental thing happening under the hood that's causing that to happen. I'm just wondering if you've hit that compute bound threshold.
Yeah, sure. So on the first thing, yes, we expose all those. I also am like personally the one who implements the Prometheus. I like personally built all the Prometheus stuff inside of VLM. So if there's things you guys want to get exposed, like I can also add it. Yeah, so we do expose that right now. I've been working on like adding queue time as well, in addition to like so queue time versus request time at like the request level. So it's a little bit more granular than just like the length of the queue. But yeah, we do expose those right now. Then as it relates to like, sorry, go ahead.
And that's actually queue time is an important one. I think, one of the meta points about like having something above servers is being able to do request hedging.
Yep.
Because like if you can have active queue management across servers, we can actually exploit some of the we don't necessarily know where the traffic is, but terminating or canceling a hedge. For those who don't know, hedging is sending the same request to two different servers. You minimize tail latency. So one of the things that we've kind of been is like, we can do much more with hedging with LLM than almost every previous workload for short requests.
So long running.
Right. And so, so just as a side note, I'll that's in what I would call that managing queues across servers, traffic stuff, which will spawn as a separate follow-up. Keep going. Sorry.
Then as it relates to like what causes these critical thresholds, you should think of an LLM server as basically having something that's like a background process running in a loop. And at each loop, you can do one of two types of work. One type of work is processing prefills. So this is new requests coming in, processing the prompts. And then the other one is processing decodes, where all the running requests, you generate one token for those requests. It turns out that because of the way LLMs work and because of the way GPUs work, adding the 50th item to the batch effectively has no impact on latency on intertoken. I'm not going to explain why that is, but just believe me. And so like what this means is you can add more and more and more things to the batch, and it really doesn't impact the intertoken latency. Up until, if you have, I think it's like up to like 64 requests, there's almost no impact. Going from 64 to 128, maybe like doubles the latency. So it's like really, really, really scalable for decoding. But what happens is the prefill times are effectively, you can think of them as like interrupting the decode batches. And so as long as you only have a couple of prefills a second, you can process them, add them to the batch, and it's fine. But what will very quickly happen is if the request rate gets too high, you start spending too much time in prefill, and it chokes out the decoding. And then the decode batch size gets bigger and bigger, and like it kind of like blows up the server. So that's like what causes this like dynamic where things can look totally fine, and then all of a sudden you like hit this threshold where like too much time is being spent in the prefill, and you just like get the whole system sort of like choked out. The other thing I would say is, in terms of what metric is going to be impacted, time per output token will almost never go up. And the reason for this is the way that the servers respond to this is by growing a queue, and like keeps itself safe by like, only allowing so many requests to be active at a time. So like a queue will sort of start growing, and your time to first token metrics will go way up, but like you'll almost never see teapot like spiking like this. In terms of actually,
and I think that getting to that distinction, because what you're saying is absolutely true, but the average per token latency, some use cases can tolerate look like high time, some can't. I think coming up with a good working model where like we can get the operators to like kind of map their use cases to those, and then the model servers, and then be able to make those recommendations. Because I would totally agree, Rob, like that is a distinction that people come from individual, like I've actually seen this, like folks from chat companies, like they completely forget that like to some people, it doesn't matter how long TTFT is, but for other use cases like sentiment analysis, like, you know, the whole token divided by the token output latency matters. So it's not always TPOT, it might be total latency divided by number of output tokens. Maybe this is like, you know, when you think about follow-ups, I know we're over time. I'd love to have, you know, a follow-up session where we continue. Like, I think we're pulling at some of these essential things, and Rob, your perspective has been like super useful. I'd love to see if we could get a working session to refine kind of like that shared mental model of model servers above and then map to use cases, and get some validation from folks in the working group from what you've seen. Because that like also shows up. We're just trying to map a lot of it so that we can say, yeah, if you want to achieve this, here's what you do.
Cool. And I didn't mean to like totally blow up this meeting. I feel bad. So yeah.
No, we appreciate it. I mean, and I think like for anybody else, like the point of these meetings is very much to get to like, are we all sharing the same set of assumptions? I think you've burst a couple of mine, Rob. You've confirmed a couple of our suspicions. So that's very useful for me. What we'll try to do is get this in a form that it's consumable by a lot of people. And as we all kind of get into that same spot, I notice like lots of people are doing very different things across the ecosystem. That's what this group is for, is to help find those concrete technical things. So thank you.
Cool. Yeah. All right. Well, I'll connect with you offline and I'll start joining this as much as I can. So nice to meet you.
Thank you, Rob. Thank you all for attending. We'll do a follow-up meeting where we'll go in a little bit more detail on this, and Ray and I will chat about like what some next steps would be.
Bye now.